Hi everyone! We already talked about two different ways to find slope of a line. We said that one way is to have a graph of that line in front of you. The second way is to have 2 points that belong to that line. And now we have the third method, third way of determining the slope. And with that method, what we need equation of that line, the equation in the specific form. It's called slope-intercept form. And this is how that form looks like. It's going to be y equals mx plus b. Let me explain what is what here. So first of all, we know that equations of lines, linear equations, they come with x and y and some other numbers. Well, I can see x, I can see y, and then m and b will be numbers, but they're special numbers. So first of all, I need to explain how to recognize equation in the slope-intercept form. It's always going to have y by itself on one side. So that has to be by itself. And that's important. If y is not by itself, it means that it's not a slope-intercept form. But whenever y is by itself, numbers m and b have special meaning. Well, number that's right in front of x, which is denoted by m, that's the slope. So we kind of get it for free. We don't even have to really look for it. It's there, it's right in front of us. So that number is the slope of the line. And we get one more number for free, special number, special value, and that is b. So that is the y-intercept of that line. Y-intercept. So that number will tell us where our graph crosses the y-axis. And because this type of equation gives us both slope and y-intercept, it has this name, slope-intercept form. So let's practice this. I have 2 examples, and for each we need to determine the slope of each line. So the first one is y equals 2 over 3x minus 4. So as soon as you look at the equation, you want to ask yourself whether the equation is in the right form. Remember, let me go back. Equation allows us to find the slope if it's in this slope-intercept form. In other words, y has to be by itself. Is y by itself here? Yes, it is. That means that right away we can say what slope is. And that is the number that stands in front of x. Not x, but whatever is in front of x. Slope is just the number. So 2 over 3, that is the slope. So see how we got an answer in a second? Slope equals 2 over 3. Easy like that. And of course, we already said that we get one more number for free, one more special number, and that is y-intercept. So this equation tells us that our graph, or this graph of this equation, will cross the y-axis at -4, y-intercept. Like that. Okay, so that was pretty easy, right? Let's try it with the second equation. Let's look at it. Now, I'm looking at it and I'm noticing that that equation is not in the form which we call slope-intercept form. In other words, y is not by itself. So here's y, and there are a lot of other things that are right next to it, so it's not by itself for sure. That means that I won't be able to tell what the slope is. -3 is not the slope. So unless y is by itself, no numbers here represent the slope. So my goal will be to get y by itself. And we'll do it by kind of like removing everything that's next to it. So first I'm going to get rid of minus 3x. Minus 3x, to get rid of it, I'll have to add 3x because since they're opposites, they will cancel. But if I add on the left, I will have to add it on the right, plus 3x. Now 12 and 3x are not like terms, so I won't be able to really combine them. The only thing that I'll write, by the way, -3y is still on the left here. The only thing I can do on the right hand side is just put them right next to each other. I'm going to start with the x term, so it's 3x, and since 12 is positive, I'll write plus 12 in this manner. Okay, we're almost there. We just now have to get rid of -3. And we know that when we're solving equations, to get rid of the coefficient, we have to divide by it on one side and on the other side. But instead of dividing this whole expression by -3, I will divide each term by -3, and these are the equivalent operations. So in other words, every single term I'm dividing by -3. Let's simplify. And -3 will cancel, so I have just y on the left hand side. Now here, 3 over -3, that gives me -1, right? So I'm going to write -1x. And then 12 divided by -3, that's -4. -4, like that. Or I can also drop that 1 and write y equals -x minus 4. They are equivalent equations. But once y is by itself, we're ready to talk about the slope. So what is the slope? Well, a number that stands in front of x, which is -1. So I'm going to write that slope equals -1. Okay, oh, and then yeah, -4 is y-intercept. So here I want to point out that if it happens that you're given an equation with no number in front of x, well, or maybe just negative sign, well, don't forget that you can always think about 1 that's in front of it. So if there's no number in front of x, well, the slope will be either 1 or -1, like in our case. So that's the way you find slope of any line if you have its equation. Put equation in the slope-intercept form, in other words, get y by itself, and then whatever is going to be in front of x, that's going to be the slope. And now we're also asked to graph each line. So we're going to graph each line by using only information that we have so far, which is y-intercept and the slope. Well, we know that to graph a straight line, we need to have at least 2 points, right? Guess what? We already have one of the points that we know, and that point is the y-intercept. So since we know where graph is going to cross the y-axis, in this case it's -4, well, that's going to be the first point on my graph. So -4. Let's see, I have to move it up so you can see -4. That would be the first point. So that means that when I'm using this method, the graphing of the line using the y-intercept and the slope, I always start with the y-intercept. That's the first point I know. So that's going to be step 1, using the y-intercept. -4. That is y-intercept. Okay. Now 1 point is not enough. I need more points. How do I find them? Well, by using the slope. Remember that slope is rise over run, and it connects points on the graph. It creates that kind of staircase along the line. So that's what we'll use. I'll have to once again recall that this is rise over run, which means that rise corresponds to 2 and run corresponds to 3. So rise is always the vertical change, it's up or down, and I just have to look at the sign of that number. Since it's +2, I will have to go up 2 units. And then run is the horizontal change, so I'll have to go either right or left, but since it's +3, I'm gonna go to the right. Right. In other words, from the point that I already plotted, the y-intercept, I'm gonna go 2 units up and 3 units to the right to take me to the next point on the line. So using slope will be step 2. Let's try it. So 2 over 3, right? 2 up, 3 to the right. So from here I go 1, 2 up. I don't put any points yet. I need to reach the end of my journey here. So, and then 1, 2, 3 to the right. And that's where I drop the point. Up 2, right 3. I'll make a note of that. 2, 3, according to the slope. Okay, now I have 2 points, and that's enough for me to draw a straight line. I know that my line is going to be more accurate if I have more points. So what I can do, I can continue constructing that staircase along my line. So it means that I can do another step. 2 up, 3 over, and that's another point. and I can do it again, 3 up and 3 over, and now I can see the pattern. In fact, I can see it pretty well to the point that I can go backwards. So if I want to go backwards, I'll have to go 3 left, 2 down, 3 left, 2 down, like that. So now I have more than enough points for me to draw a nice straight line. Okay, so here it is. So that's going to be the graph, and again, we constructed by using only the y-intercept and the slope that we got from the equation. Let's repeat it again with the second equation. So remember, step 1 is to use the y-intercept and plot the y-intercept, which is -4, or it happens that it's -4 again. So I got the first point, and now I'm going to use slope to find more points. But let's look at the slope. It's -1. Well, the way we use the slope, we have to do rise over run. So we need 2 numbers, but we only have 1 number here. It's -1, right? What do we do in this case? Well, every time when slope is the whole number, 5, 6, 10, -20, whatever it is, -1 in our case, and you need to use the rise over run, just put that number over 1. We can create fraction out of any number this way, right? So now it's rise over run. Rise is negative. So what does that mean? It means that I'll have to go 1 unit down. And then the run is positive, so I have to go to the right. Rise over run. Rise over run. Okay, let's try it. 1 down, 1 to the right. 1 down, 1 to the right. 1 down, 1 to the right. Okay, so that's going to be my pattern. And once I figure it out by going 1 down, 1 to the right a few times, I was able to find a bunch of points. But once I see the pattern, I can see that staircase. I can build it in the opposite direction if I want more points. Okay, I think that would be enough. So let me connect them. So that's the line I obtained. And at the end, let's confirm that the lines that we obtained are consistent with the slopes, or at least like with the signs that slopes have. So in the second case, slope is -1, slope is negative, and yes, we can see how line is decreasing. And for the first example, slope is 2 over 3, positive 2 over 3, and this line is increasing. So that part is consistent. But to summarize what we talked about in this video, for this method for finding the slope, we have to have an equation in the slope-intercept form. That is when y is by itself. So that's the way to recognize it, or the way to obtain it. Y has to be by itself. And when y is by itself, number in front of x, not together that number and x, but just the number in front of x will be the slope.